Hello again. In this lesson we're going to look at an important new concept called baseline accuracy. So we're going to actually use a new data set, the diabetes data set. So I've got Weka here. I'm going to open diabetes. There it is. So a quick look at this data set. The class is tested negative or tested positive for diabetes, I guess. We've got attributes like preg, which I think is to do with the number of times you've been pregnant, age, which is the age. Of course, we can learn more about this data set by looking at the ARF file itself. Here is the diabetes data set, and you can see it's diabetes in Pima Indians. A lot of information here, the attributes, number of times pregnant, plasma glucose concentration, and so on, diabetes pedigree function. Anyway, and I'm going to use percentage split, this one, and I'm going to try a few different classifiers. Let's look at J48 first, our old friend, J48. So we get 96% with J48. I'm going to look at some other classifiers. You'll learn about these classifiers later on in this course, but right now we're just going to look at a few. Look at naive Bayes in the Bayes category, the naive Bayes classifier, and run that. And here we get 77%. A little bit better, but probably not significant. Let's choose in the lazy category. I'm going to choose IBK. Again, we'll learn about this later on. And here we get 73%, quite a bit worse. And we'll use one final one, the partial rules. In the rules category, the part procedure. And here we get 74%. So we'll learn about these classifiers later, but they're just different classifiers, alternative to J48. And you can see that J48 and naive Bayes are pretty good, probably about the same. The 1% difference between them probably isn't significant. IBK and part are probably about the same performance, again, a 1% between them. There's a fair gap, I guess, between those bottom two and the top two, which probably is significant. Anyway, I'd just like to think about these figures. 76%, you know, is that good to get 76% accuracy? Well, if we go back and look at this data set, the class, we see that there are 500 negative instances and 268 positive instances. So if you had to guess, you'd guess it was going to be negative, and you'd be right. 500 over 768, the sum of these two things, the total number of instances, you'd be right that fraction of the time. 500 over 768 if you always guess positive, and that works out to 65%. Actually, there's a classifier, a rules classifier called 0R, which does exactly that. The 0R classifier just looks for the most popular class and guesses that all the time. If I run this on the training set, that'll give us the exact same number, 500 over 768, which is 65%. So it's a very, very simple, kind of trivial classifier that always just guesses the most popular class. It's okay to evaluate that on the training set because it's hardly using the training set at all to form the classifier. So that's what we would call the baseline. Using the baseline gives 65% accuracy, and J48 gives 76% accuracy. So it's significantly above the baseline, but not all that much above the baseline. So it's always good when you're looking at these figures to consider what the very simplest kind of classifier, the baseline classifier, would get you. Sometimes baseline might give you the best results. I mean, I'm going to open a data set here. We're not going to discuss this data set. It's a bit of a strange data set. They're not really designed for this kind of classification, but it's called supermarket. I'm going to open supermarket, and without even kind of looking at it, I'm just going to apply a few schemes here. I'm going to apply 0R, and I get 63%, 64%. I'm going to apply J48, that's down here, and I think I'll use a percentage split for evaluation. It's not fair to use the training set here. So now I get 62, 63%. That's worse than the baseline. If I try naive Bayes, these are the ones I tried before, I get again 63% worse than the baseline. If I choose IBK, that's in lazy IBK, this is going to take a little while here. It's a rather slow scheme. And here we are, it's finished now. Only 38%. That is way, way worse than the baseline. And we'll just try partial decision rules. And here we get 63%. So the upshot is that the baseline actually gave a better performance than any of these other classifiers, and one of them was really atrocious compared with the baseline. This is because for this data set the attributes are not really informative. So the rule here is, don't just apply Weka to a data set blindly. You need to understand what's going on, and when you do apply Weka to a data set, always make sure that you try the baseline classifier 0R before doing anything else. In general, simplicity is best. Always try simple classifiers before you try more complicated ones. Also, you should consider when you get these small differences whether the differences are likely to be significant. We saw these 1% differences we saw in the last lesson. They're probably not at all significant. We should always try a simple baseline. We should look at the data set. We shouldn't blindly apply Weka to a data set. We should try to understand what's going on. So that's this lesson. Off you go and do the activity associated with this lesson, and I'll see you soon.